In this video, I'll talk about IPv4. IPv4, or Internet Protocol version 4, is what's in use on the Internet today as a communications software protocol. It's also widely used on internal enterprise networks, and it stems from the 1970s. However, IPv4 was not designed initially with security in mind. So any application-specific transmission security has been an afterthought since the 70s, such as HTTPS to secure an HTTP web server. However, HTTPS is specific to the web server, so if we wanted to secure 20 web servers, we'd have 20 configurations to go through. Alternatively, with IPv4, we can use IPsec, IP security, which is not application specific. So, for example, if we enabled IPsec on all of our internal clients and servers, then what it means is regardless of which transmission protocol is being used, everything would be encrypted and potentially even digitally signed. IP addresses are 32 bits long, for example, 199.126.129.77. So they're expressed in decimal form or base 10, where each 8 bits or byte is separated with a dot. The subnet mask determines which part of the IP address identifies the network versus the host. And the subnet mask is expressed, again, either in decimal base 10 form or in CIDR form. So in our example, where we have an IP address of 199.126.129.77, if our subnet mask happens to be 255.255.255.0, that means that the first 3 bytes identify the network. And in this case, that means the network is 199.126.129. So the last number, 77, then, would be a host on the network. Now, with the 255s, that is the subnet mask being expressed in decimal form. In shorthand, it would be simply /24, which identifies the number of binary bits within the subnet mask. There are some special IPv4 addresses like the local loopback, which has an address of 127.0.0.1 on a device, and we use this if we're testing our local IP stack when troubleshooting. There's also the automatic private IP addresses, which are called IPv4 addresses. They have a prefix of 169.254, and a device will be configured with this when it can't contact a DHCP server. Now, this IPv4 address is only usable to communicate with other IPv4 hosts on the local area network only. An address of 0.0.0.0 means that there is not yet an address that's been assigned to a device. In the routing context, 0.0.0.0 means the default route. Network broadcasts for all networks have an address of 255.255.255.255. So all of the binary bits are set to 1. Routers don't forward broadcasts. Then there are 3 private ranges of IP addresses designed to be used internally by companies that will not be routed by internet routers. They are the 10.0.0 range, the 172.16.0 range, and the 192.168 range. Now, there are variations. So instead of 192.168.0.0/16, for example, on a home wireless network, we might instead have 192.168.1.0 with a /24-bit subnet mask. There are additional IPv4 settings beyond the IP address, subnet mask, and the special addresses to keep in mind. The default gateway is the IP address of a router interface on your network that you use to communicate outside of the LAN. There could be multiple default gateways on a single LAN, and you could send traffic through them depending on where the destination is. Now, one of the dangers with routers and default gateways is ARP cache poisoning. If a malicious user can get on the network, then they could set up a malicious host that sends out a periodic update to every device on the network claiming to be the router. In other words, basically telling everyone, update the MAC address that you have stored in memory for the router with my MAC address. Now, that's fine, but what it means is that all the traffic then gets routed through the malicious host, which the host would then probably continue sending it through the internet. The bad part is that all traffic would be seen by the malicious user. For example, here I'm going to type ipconfig in a Windows command prompt. Now, for my network interface, what I want to do is take a look at the default gateway. So here I see a default gateway address for my Wi-Fi adapter, and the address is 192.168.1.1. If I clear the screen and then type ARP space -A, it shows me the ARP cache in memory on my client station, which basically shows me the physical MAC addresses for devices on my LAN and the corresponding IPs. Now, I can see here I've got an entry for 192.168.1.1 along with the physical or MAC address of my router. So ARP cache poisoning sends out an update that changes this physical address for the default gateway, essentially tricking machines into sending traffic that's destined for the default gateway to the malicious host. So it's paramount then that we protect how people get on our network in the first place. The next big IPv4 setting would be the domain name service server, or DNS server or servers. It's the IP address of one or more lookup servers, and they also do not have to be on your network like the default gateway does. It allows connecting to a service by name, which is easy to remember, versus the IP address, which is difficult to remember. You should configure more than one DNS server, so if one fails, devices can still resolve names to IP addresses by failing over to the next DNS server configured. One danger with DNS, and there are many, is DNS poisoning, which is also called DNS spoofing. Essentially, this redirects legitimate traffic to a malicious host. So you can imagine if you frequent your online banking site and a malicious user hacks into a DNS server that you point to, they could redirect that same URL, that friendly name you're used to typing in, to the IP address of a web server under their control that looks like the real website, but isn't. And it might be used to gather your online banking credentials. IPv4 port address translation allows internet access through a single public IP address on the PAT router. It also hides internal IP addressing schemes for internal hosts going through the PAT router, and also it doesn't allow internet-initiated connections from the internet to internal hosts. Pictured in our diagram, we see three hosts on the inside network with addresses such as 10.0.0.1.2 and .3. They would be configured to point to their default gateway, which is just a router, which in turn is configured with port address translation. Now that gets them out to the internet. Now what's interesting about this is a PAT router has a memory table where it tracks the inside local address, so the internal addresses, as well as an inside global. Now the inside global would use the public IP address of the PAT router along with a unique port identifier, which we see here in the form of 1000, 1001, and 1002, so it knows how to get traffic back into a host that requested something on the inside. In this video, we talked about IPv4.